Welcome to Oryx Learning. Today's lesson is going to be on Unit 1, Real Numbers, Lesson 5, Negative Exponents. So to start off, we have a common black ant that is 3 to the negative 5th grams, can carry about 3 to the 3rd grams on its back. About how many times its weight can an ant carry? If you're curious about this answer, follow along in the lesson and we'll discuss it at the end. So we have two properties that we're going to talk about with zero exponents and negative exponents. The first one being the zero exponent property. The zero exponent property states that any non-zero number to the 0 power is 1. So if x to the 0 equals 1, if x does not equal 0. And the reason this is, if we look at the pattern that we have, right, 100 is represented as 10 squared, 10 times 10. Dividing by 10, we go down to 10, which is 10 to the 1st. Dividing by 10 again, we go down to 1, which would just then be 10 to the 0. Right? Each time you divide by 10, the exponent goes down by 1. You can also think of it as the exponent representing the number of zeros. So 100 has 2 zeros, 10 has 1 zeros, 1 has 0 zeros. Our second property is the negative exponent property. Any non-zero number to the negative n power is the multiplicative inverse of its nth power. So if you have x to the negative n, that would equal 1 over x to the n, and 1 over x to the negative n would equal x to the n, as long as x does not equal 0. So following along that same pattern up top, if we go from 1, divide by 10, that's 1 over 10, subtract 1 from the exponent because we divided by 10, 0 minus 1 would be 10 to the negative 1st. Dividing by 10 further, we go to 1 over 100, subtracting 1 from the exponent, 10 to the negative 2nd. So if 10 squared is 100, 10 to the negative 2nd is 1 over 100. One more real-life example here. We have if you have a frown to the negative 1st power, it turns it upside down to a smile. All right, our first example, if we want to evaluate negative 3 minus 5. When subtracting numbers that are the same sign, both positive or both negative, you simply add the numbers together and then use the original sign, either positive or negative. So in this case, we have negative 3 minus 5. Well, 3 and 5 gives us 8, right? 3 plus 5 is 8. And then taking the signs of the original, that would just make that negative 8. So negative 3 minus 5 is negative 8. For the second example, we have 1/3 to the negative 2nd. Whenever we're evaluating a power with a negative exponent, we want to first take the reciprocal of the base. So our base in this case is 1/3. Taking the reciprocal would make it 3 over 1. So 1 over 3 to the negative 2nd is 3 over 1 squared. Right after we take the reciprocal, we change the exponent to positive. Then we can simplify and evaluate from there using our properties of exponents. In this case, we have the power of a quotient, which would make it 3 squared over 1 squared, which 1 squared dividing by 1 does not change the outcome. So we'll just go with 3 squared. 3 squared is 9. For the next example, we have 7 to the negative 3rd times 7 to the 0 divided by 7 to the negative 5th. So if we want to evaluate an expression like this, when dividing like bases, we subtract the exponents, and when multiplying like bases, we'll add the exponents. So in this case, if we look at the numerator, 7 to the negative 3rd times 7 to the 0, we can change that, move that 7 to the negative 3rd to the denominator, and in the denominator we have a 7 to the negative 5th, which we can also move to the numerator and make it 7 to the 5th. And also keep in mind, anything to the 0 is 1, so 7 to the 0 just became 1. So now we're left with 7 to the 5th divided by 7 to the 3rd. We'll subtract their exponents. 5 minus 3 is 2, and 7 squared, or 7 times 7, leaves us with 49. So that expression simplifies down to 49. Now we have a to the third times b to the 0 over a to the negative fifth times b to the negative second. Very similar to the last problem, right? We can move those negative exponents to the numerator and make them positive. Or we can just treat this as a like-base division problem and subtract the exponents. So we have 3 minus a negative 5 for the a's and 0 minus a negative 2 for the b's. Minus a negative becomes positive, so 3 plus 5 is 8. 0 plus 2 is 2, leaving us with a to the 8th, b to the 2nd. All right, a decimeter is 10 to the negative 1st meters. A kilometer is 10 to the 3rd meters. How many decimeters are in a kilometer? So first we're going to set this up as a division problem. 10 to the 3rd divided by 10 to the negative 1st. Two ways of looking at this. We can either just subtract the exponents with these like bases, or you could move the 10 to the negative 1st to the numerator and then add because you'd have multiplying like bases. So in this case, 3 minus a negative 1 would become 3 plus 1, which is 10 to the 4th. And 10 to the 4th is 10 times 10 times 10 times 10, which will leave us with 10,000 decimeters are in a kilometer. Back to our ant problem. So we have this ant that is 3 to the negative 5th grams carrying something that's 3 to the 3rd grams on their back. In order to solve, we're going to divide 3 to the 3rd divided by 3 to the negative 5th. Like bases, we'll subtract the exponents. 3 minus a negative 5 is the same as 3 plus 5, which gives us 3 to the 8th. 3 to the 8th, 3 times 3, etc., will give us about 6,581. So an ant can carry approximately 6,581 times its own body weight. Impressive. In conclusion, don't forget we have our zero exponent property. Any non-zero number to the 0 power is 1. And our negative exponent property, any non-zero number to the negative nth power is the multiplicative inverse of its nth power. So that has been our lesson on negative exponents. I hope you enjoyed.